So I work for a company called EasyMile, which basically is a software company that targets driverless vehicles. I'm saying vehicles in general because we talk about driverless cars, but we're interested in driverless anything. So we'll work with bus manufacturers or forklift manufacturers, tow trucks, even washing machines, eventually car manufacturers, and help them, these are companies that usually build driver-full vehicle. And we help them essentially make driverless versions of them. We give them specs for the sensors that they should install. We have our software that can be installed on computers that we maintain and support. And then they make it a product or don't, or you continue doing R&D with us or alone. So we're mainly a software company, but as Alan Kay famously said, people who are really serious about software should make their own hardware. So there is one thing that we sell directly and that we are exclusive suppliers of, and it's the EZ10 driverless shuttle bus. It's a fully electric, driverless from the start, small minibus with room for 12 people. We've been building them since the start of the company. The whole company is 4 years old, by the way. We started in 2014. And we've been building them with Elixir, which is a French manufacturer. And in late 2015, we had our first public productization of it, I would say. This is in Singapore, in Gardens by the Bay. We offered with our partners there a driverless shuttle in this amusement park in Singapore that has been in continuous operation since and is, we believe, the first publicly available driverless shuttle transport in the world. So we're pretty happy about that. We've done a few more since then, by the way. We have about 40 of these vehicles currently on the ground everywhere in the world, from Australia to Scandinavia and North America. We were featured last week in Forbes.com, by the way, and the title, this is not a joke, Ugly But Useful. Which I think is kind of amazing. The text of the article is fairly positive, but that's the title, that's what they focused on, which I think is quite awesome because it's a bus. I mean, buses are not generally known for being especially attractive. But if you put a bunch of technology in it and do a demonstration and seem high-tech, you'll get journalists to go, I don't know what this means, but I wouldn't have chosen those colors. So, internally, the demo is going great, by the way. It's in Stockholm, I believe. So, of course, internally, we had to joke a little about this. We made a few unofficial logos for the product and also product placement things. As I said, my communication director is going to kill me. But jokes aside, this is quite serious business. We're dealing with, we're partnering with basically the who is who of transportation companies and transport operators in 4 continents, and it's generally going pretty well. So the robot itself, the sensor and artificial intelligence is pretty challenging. But what I was hired to do, and what I'm going to talk to you about, is everything that's going outside of the robot. So the robot or the car, the thing. Because some of the decisions can be made by the vehicle itself, but some of them are global. So global to an entire site. So if you have 5 or 10 or 20 vehicles going on a site, and you have one passenger who wants to have a ride from there to there, or we have to plan the whole thing, you need a centralized architecture above that, which is generally in the cloud, which will talk to traffic lights, will talk to different applications, will offer monitoring, fault prevention, and those things. And we had a few proof of concepts from the get-go, but about none of them, we weren't very happy about any of them. And about 2 years ago, we decided to start from scratch and build it in a new, build a new solution from the ground up. We looked at a few technologies and eventually settled on Elixir. which was a bit riskier at the time than it will be now, because it was, as I said, 2 years ago, the ecosystem was a bit less well known. The first books had just come out. And also at that time, we had about one full-time equivalent guy working on this, which was half me and half one of my colleagues at the time. But we just went for it, and we put this, we grew the team, and we put this in production late last October. And it's been transitioned, and it's been fairly successful. And it's now the solution that we built is used to control all of those 40 vehicles currently operating around the world. And hopefully a few dozen more we hope to sell in the coming year. The team has grown a bit too. This is us last Friday for the obligatory Friday evening beer. And this is not all of us. There are we have two very important teammates in Singapore, but we couldn't find them over just to have a beer and take a photo. But yeah, that's basically we built a product that never really existed, because there are no integrated fleet management for autonomous vehicles, and that poses very specific challenges. In about a bit less than 2 years, while scaling up both deployment and team size tenfold. So I won't say that this was perfectly smooth and easy and things, but it worked out, in the end it worked out pretty well. And I want to share what we've learned with doing this, and essentially I've set up this talk as a sort of a letter to myself, and thought about 10 things I really wish I knew 2 years ago. So just out of curiosity, how many of you are using Elixir in your day job with actual clients? That's a lot more than last year. That's awesome. So I'll switch. And how many of you have been using Elixir for more than 2 years? Much less. More than 1 year? Okay, that's good. So just to be clear, so some of this is going to be, it's sort of all levels talk. Some of this is going to be fairly well-known stuff for half of you, if I count well. Some of this will be fairly, I think, very useful. Some of this, I hope, is going to be wrong, and you'll come see me after the talk and say, you're doing this completely wrong, this is how you should do it, this problem has been solved 1 year ago by thingy. And I'd really love for that to happen. So please don't hesitate. So just to be clear, what we're going to talk about is everything that's in that blue cloud in the middle. So this is a fairly low resolution pictures of one of our interfaces, which displays a map and has controls for all the vehicles and all the traffic lights and infrastructure going on in the ground at that moment. But it's not just that interface that is important, it's the fact that it communicates, the underlying backends communicate with traffic operators, like it could be the Warsaw public transportation, it could be Google Maps, it could be larger multimodal organization tools, planning tools. It could be, we have a couple of applications for both operators, bus operators, passengers themselves, and sort of static displays that show the upcoming estimated time of arrival for the next shuttles. We have applications that allow people to ask for on-demand buses, and we also do fault prevention and data mining. So we upload all of the about 200 telemetry parameters to an ELK database. That is going to be out of scope for this presentation. So I'm talking about the whole blue cloud there in the middle. And it has a lot of microservices and stuff and tag, but the overall technology stack is probably not surprising, it's not very surprising to any of you. The protocol we used to communicate with the vehicle was built completely from the ground up, because nothing existing could had what we wanted. No one ever tried at that point to design a protocol to control a fleet of autonomous vehicle. It's serialized as protobuf for performance reason, and we transport it for the moment in TCP/IP, but we have prototypes on MQTT, and we're switching to MQTT in the coming months. Everything that's in the cloud is running Elixir. It's implemented in Elixir. We use Phoenix for the part that it's pretty good at, so mostly as a REST API server. And the front ends that we use are pretty standard React Redux stuff. We use ES6 branches or Builter. We have Flow for time checking. There's Jest storybooks and about 12 more libraries. You know how front-end projects are. And deployment is handled by Kubernetes, and our cloud provider is mostly AWS. Does anyone, so Amazon. Does everyone, who doesn't know what Kubernetes is? Just to be sure. Okay. Who has heard the name but isn't really familiar with it? Okay, fair enough. Just for the couple of you, Kubernetes is a Docker orchestrator. So it's a thing that allows you to describe a service by saying that it's to provide, for example, a fleet management solution. You need one web server that is this Docker container that will serve a front end, and one fleet management server that is inside this is a container that you have to open those ports, and inside there's an Elixir server that answers it, and a couple more things like WebRTC server. You need 5 of these servers. I want one new one in Singapore now. And I want you to make sure that these are continuously working, and if any one of them takes too much memory or is stop responding as a health check stops responding, you just restart it. So that's what we that's what we use for deployment and high-level deployment and monitoring. So the first of my 10 points is very, as I said, will be very straightforward for some of you, but it's a mistake that every single one would join the team, and every single one person I've talked to who started Elixir made at some point, which is that GenServers, confusing GenServers in an Elixir architecture with classes in an OO architecture. To put that in, to make an example of this, when you're looking at the high-level architecture for piloting, for commanding vehicles, it's going to look very much like something like this. An objective, we have a few objectives, where an objective is something that a human being wants the buses to do. Very high level, like I want 2 buses to do this line, go to station A, B, C, and back to A, and circle there forever. And there are a number of vehicles on the other hand, and these vehicles understand commands, which are very direct, atomic things, like open your doors, go through that track, turn left 90 for those who know logo. And then you have to build something a bit more complex, like a mission, that will be the succession of commands that will bring the vehicle to station B to open its doors. And it can be, go to that intersection, wait to make sure that this intersection is something that you have that's reserved for you, then go through, then open your doors and stuff. But it's a fine thing. And then you have a plan that is something that is essentially a process. This is tricky, process, or an algorithm to generate missions. So for example, generate the mission to go to B, and then use the mission to go to C, and then do a mission that go to A, and then repeat forever. So all of those things, you can, we've done this exercise a lot in job interviews, and everyone sort of converged to something like this with different names. And that's good, it really works. The thing is that everyone who's starting Elixir then says, okay, I'm going to make a chain server out of each of these things. And have them discuss and pass messages. And I have them subscribe to information coming from the outside, like the state of the vehicle or what the front end is saying. And if you do that, you get to a solution where first all of your code looks like this, like all of your functions inside each of your GenServers does very little. It just takes a thing and forward the message to its 4 other partners, like when the plan knows that it has to stop, it has to tell its objective that it's not working anymore, it has to abort the current mission, it has to clean up activity, which is something else. And you'll see that there's very little business logic in there. There's very little actually directly happening. You're just forwarding messages around and hoping that things work. And I think the reason people do that is that you get, when you've read books and blog posts about Elixir or Erlang or Haskell, by the way, it's the whole thing with the whole category of language, you get the idea that, hey, concurrent and distributed systems are really easy now, because every problem you can have is solved. And as some of you are nodding actively, this is not true at all. What Erlang does is get rid of one specific class of problem, which is shared memory access in distributed systems. But concurrency and distributed state are still going to be useful, are still going to be awful, the same thing. And they're still going to be really error prone because you have no idea in this specific situation in what order the different actors will receive the order to abort their current mission and change what they're already doing. And we did that at some point, which I'm a bit ashamed to say, and everybody does. You have to be really careful to do that. In reality, after a lot of soul searching and trying to debug the 400 different sequencing of events that we sort of built for also no reason, we came to a sort of rule of thumb that you really need a gen server and an independent concurrent process when you have something outside your system that has a definite life cycle, and you have no other existing process that can handle it. So vehicle is definitely a gen server. You have one vehicle will be that point of contact with the network interface of that vehicle, and that will be a gen server. And maybe conceivably objective in this case. It depends on what you're doing. But everything else should be modules and functions and pure functions. Again, sorry if this sounds obvious, but it took a while. I had to teach this to a lot of different people, and it took a while to really express what's the problem with it. What sort of goes with this is that all your business logic, everything clever that you're doing and complex should go into pure functions. And partly because you have less processes, but also mostly because that makes them testable. If you look at the code, if you look at that code before and you try to put it into ExUnit and have something that ensures that everything is happening as you want, it's going to be really difficult to do, because you have to mirror a whole supervision tree with your different actors, and then assert their state every time you do something, and you have to wait for it to happen. It can be done. It can absolutely be done, but it's a lot of work, and it leads to a very brittle test suite, because whenever you try to change anything inside that, you have to change your entire test, because it's not really testing the whole process. It's the whole algorithm. It's testing parts of it and the way you've implemented it. However, if you have one pure function that says, if you get this new vehicle states, and the current plan says this, and the current mission says this, and the current objective is this, then you can just assert that the result is what you'd expect. And it's all in one place. It's all in one precise place. And as soon as you realize this, you discover how great life is. Continuing in this matter, it sounds obvious, but ExUnit is actually a tool for unit testing. I know that would seem self-evident, but it's not necessarily, because it's the same, because it's the one tool, the one library for testing that's common and ubiquitous in Elixir. We tried for a long time to do what would be integration testing, and trying not test the whole system, but try to combine different actors and make sure that we had the behavior we wanted. And we had to do that. We were obliged to do that because of the architecture with which we needed multiple actors to actually do anything interesting. And, well, it's not very good at that. ExUnit is a very great, is a great library for testing pure functions or asserting things about a single actor. But if you try to do a little more complex integration thing, you quickly run into a flaky test suite because the isolation of the different tests isn't what you'd get, for example, in Java or most languages that you usually have. Or you can, Java essentially forks its environment for each test suite. And Elixir doesn't do this, and it's super confusing. The good news, though, is that ExUnit is very good for very straightforward, pure unit testing, and you don't actually need medium tests. You don't actually need tests with 3 or 4 actors that collaborate. We tried to do it for a long time, but actually, why the usual, the sort of Martin Fowler testing pyramid assume that you have a lot of unit tests because they're really fast, and you have a few integration tests that test a little submodules, and then you have just 1 or 2 UI tests because the full end is very difficult to test and very slow. Well, that wasn't our experience. We ended up doing just unit test for all the business logic in pure function style. And then we built really end-to-end test where we just fake the vehicle and fake the front end and just push on the API and see what goes out the other end. And to make sure that would be a pure black box test and we wouldn't be tempted to assert things about the implementation, we wrote all of that in Python. So you can directly communicate with the Elixir thing. And it's a bit of an ad hoc solution, I guess. This is one of those things, the first 3 were really stupid things that we did at the end that I hope someone will not do because they've been to this talk. This is something where I'm a little less sure, and I'd love your feedback if this architecture seems fine or you have comments about this. But our experience since then is that with a relatively fast integration acceptance test suite, which runs in about 2 or 3 minutes, we get rid of 80% of regressions, and it's a pure black box, so we can change everything in the architecture of the Elixir side while being sure that we're still compliant with our specs. So that has been working really great for us, I hope. And we'll continue with that. The 5th one is that monolith is not a bad word. We had this, especially since we're doing Kubernetes and we have all these Docker things and we can have microservices everywhere. We started doing microservices everywhere. We'll have these independent things. And what used to be that blue cloud I showed you at the beginning was actually a stack of different stuff. We had a gateway which was in Elixir and acted basically as a hub that just allowed the vehicle to connect and then forward it to other different services which would push to ELK and do other things. The main one was something we call the fleet manager, which did the whole objective mission plan things that I described in the first point. And then that would, but in a very sort of abstract sense, and we moved from user interaction. And then we had a control center that was essentially Phoenix in practice that would convert things from the front end in REST to things that fleet manager could understand. And then the front end, which was obviously JavaScript. But those 3 things were essentially 3 services implemented in Elixir, in each one deployed in a different VM and different Docker container. And we treat the deployment and we iterated a bit on how these different things would communicate together. The gateway and fleet manager used a protocol, a TCP/IP protocol very similar to the one the vehicles used. And the fleet manager and control center used distributed Erlang, actually, pub sub over distributed Erlang. And we learned how to do distributed Erlang over Kubernetes, which is a great thing, and it's almost magical when it works. And so there's a bit of tricking to do, but it's quite amazing how well it worked when you sort it out. And we experimented with different pub sub libraries to do that. And then at some point, someone just raised his hand at a meeting and went, guys, why are we doing any of this? I mean, we have different services that are all implemented in the same language that want to talk to each other. Why don't we just put everything together? And you know, the response was, I don't know, service-oriented architecture and separation of stuff. We should try just putting them together in a single VM and see how things work. It turns out it works really well. It's simpler that way, and it's not only simpler, but even though. So what we have is that everything that's in Elixir is now in one single VM for the site. And the sort of lessons learned there is that when you look at Docker orchestrator and the microservice architecture, and when you look at GenServers and actor-oriented architecture inside VM, they look kind of the same. They're about the same. And Elixir itself, well, Erlang, I should say, Beam, is actually pretty good at isolating different services and making sure you restart them as when some of them crashes or does something crazy. And message passing between them is kind of the same thing as REST APIs between microservices, but it's actually much, much faster. You know, Docker is pretty quick at restarting, but it's orders of magnitude slower than a GenServer crashing that would restart and a supervision tree recreating itself. Also, it's a lot easier in this case to move code around, which means that if you somehow misspelled your problem in your architecture from the start, and you want to move some of those concerns and responsibilities from one part of your Elixir code to another, it's much, much easier than doing this across microservices. And so you'll do it. And so pretty soon your architecture will actually be, even though it's monolithic, much more separated and with much more self-contained element. So, well, do that. A sixth one is one where I would like to whine a little bit. There's a lot of tutorials and examples and books which sort of assumes that you're going to deploy to Heroku because you're doing a web app and you're very cool, and you're doing a chat or something and you're awesome and you're going to be the next Facebook. And that's fair, that's nice. But I've used Heroku in the past, it's a great service. But sadly, we can't do that, and many people can do that. We have different clients who need specific versions of them. We have clients of the software suite. We have clients who who absolutely need our software to run on their own server that is isolated from the internet. We have to be able to take version 17.9.4 with B for this client that we had a while ago and it's now in production, and have it run on a local machine to do some testing and see if it would work with the new version of the software, the vehicle, for example. And when you do that, when you have to do that, you have to go into distillery and conform and so do runtime configuration. And I had a lot of things to say about that, and then I watched the talk from Albert Sack yesterday about deliver your code while it's hot, about continuous delivery with Elixir, and most of what I wanted to say was going to be redundant, so I cut it. But the short version of it, I hope you'll be able to, those who missed this talk will be able to see it fairly soon. The short version is we don't really have a sort of accepted, clear version of doing runtime configuration that works with most libraries, that every library that you want to use. And that's something we're trying to contribute to and improve from our side. I have high hopes for the next versions of Distillery. That it's something you have to be aware that it's something that will eat a little at your time as you're trying to deploy and deal with these things. The flip side of this is if you can have one single version in production and you can use Heroku, then do it. It's simple. Seventh thing is a little whining as well. You often hear that Erlang is 30 years old and you'll get good libraries for everything you need. This is not true. You'll get very good libraries for most of what you need, but probably not everything if you have fairly wide need, in most situations, at least in our experience. So we ended up writing our own protobuf encoding and decoding library, and we've open sourced it. It's on GitHub on EasyMile's GitHub website. Not because the libraries didn't exist, but because they didn't really match our specific need on, regarding performance and type checking. It's just a specific combination that no one had addressed before. There are other things where we would like libraries to exist, and it's too much work for us to do them, sadly. One example is we have a tool that allows to create new deployments and monitor deployments, and it basically calls the Kubernetes API, and calls Helm API for those who know about this. And there are no existing Elixir or Erlang solutions to do that. And implementing them, because Helm is something that Google developed and it's a bit involved, would require a solid implementation of rarely used features of HTTP2 and GPRC, so Google, gRPC, Google Remote Procedure Call. So yeah, we would like to do it. We don't really have the bandwidth to address those things now. So we built that tool. The tool that we have right now is an Elixir tool that just calls the Elm and kubectl binaries from the shell. And calling things from the shell in Elixir is something that you generally don't want to do. It's generally not a happy experience. So in retrospect, that tool, that specific tool should really have been written something completely different from Elixir. I think Golang is the obvious one because it has all the libraries. It's something you have to be aware of, and you have to be careful about. And you know, this is like 4% of our code base. It's not a huge deal if 4% of your code base isn't Elixir. Be aware of those kind of things and try to de-risk them as you go along. Enough whining. The Elixir community is really great. I'm sorry for pandering, but it's true. We asked a lot of questions on the Elixir forums and on Slack, and they were generally answered really fast. We try, now that we have learned a few things and we have a bit more experience, we try to give back and answer the questions. To be fair, though, well, sort of the flip side of this is many of our questions, which are about configuration and distillery and obscure needs about conform and distillery, just couldn't be answered because it's a problem that nobody really had before. It's a combination of problems nobody really had before. So it's the community is awesome. We're all trying to learn together, but you know, sometimes it's not entirely enough. The ninth point is that Elixir is fast enough. That's part of the reason. Part of the reason we had sort of a microservice-y thing split across many things was that we thought we had graph traversals to do and optimization and your sort of traveler's problem. So we thought we really quickly will need to offload some of this stuff to something written in C++ or Go or something like that. And actually, we never needed to do that. And we have a lot of headroom right now, and we don't have any performance problem that couldn't be solved by just throwing more code at it and throwing more cores at it and optimizing a little. So compared to my previous experience in Rails and Python, the difference is quite spectacular. And that's, again, don't be afraid of performance issues unless you have a clear, really high computing need, and then, you know, do some testing, and you may be pleasantly surprised. The 10th point is something, it's more an anecdote that I want to say. Being able to log in on a production server and just do inspection and see what's happening and write code live is quite amazing. It's very useful in debugging. It's also very useful in real production needs. So we have, that's also something I probably shouldn't be talking about, but we had a demo recently that we did on a really small cluster, Kubernetes cluster, where there was also an ELK provider running, and that ELK database got a bit overwhelmed. So essentially publishing node that was pushing to ELK got its message queue started to grow. And usually we let that happen because you absolutely don't want to lose a message. And if you have a bandwidth problem, we have other ways to identify this and scale ahead of time. Here it was, it was a new version of the software. It hasn't been fully tested, but we were still demonstrating some of it to clients. And we just logged onto the system and saw that this was happening. And we just wrote a bit of code to in real time just cut that message queue and drop that message queue as we go along. So I wouldn't recommend doing this generally. I certainly wouldn't recommend planning on doing this to solve performance problems, because that's not it. I'm just saying that if you do this for a while and you have to demo experimental version to real people, one day you're going to do something like that. You'll be really happy really glad for the possibility that and the language that supports this. I'm running a little ahead of schedule, so I have bonus points that I would like to add. My experience has been that compiling Elixir takes a bit of a time, especially if you have dependencies and stuff. And if you write codes with quite a bit of macros, it can add up. And because of the way configuration can affect virtually any of the dependencies, you have to recompile stuff very often. And I understand the trade-off. I mean, having compilation time configuration is awesome. But when you're recompiling your web server like Kobo for the 12th time in the same day, it gets a bit frustrating. So I'm mostly asking, I'm mostly saying I miss jar files a little, which is a blob of compiled thing that you can just import and use, and it will always be in the same situation. And I'm curious about what you guys feel about this, and if you have a solution or just the way you deal with it. We've tried a little sort of move beam files around, and it doesn't really work. So if we're just lazy and impatient, or if that's a real problem, and someone has ideas on how to solve it. Another one, I don't know if this will be well received or not, depending on who's in the room, but Erlang programmers are awesome and you need one. One side of it is that Erlang programmers can be very annoying. I don't want to stereotype it, but they really are. They will tell you that Elixir is just syntactic sugar and it's just something on top of it. It doesn't really change much, and but it has, the macro system is awesome and it really is more concise and stuff. No, nobody needs this stuff. Language design clearly peaked in 1986. But they do have kind of a point, which is most of the problems you have with architecture and runtime configuration and production things are going to be problems and challenges that they've been working on for decades and essentially solved. So if you can find a good Erlang programmers with years of experience, you want one on your team. In completely unrelated note, we're hiring. And the last thing is high availability is built in, which is a bit of a tough claim, but actually, as this talk is called, Building a High Availability Platform Using Elixir, while I was reviewing the slide, I was realizing that I'm not addressing it very much as high availability as you usually do. And that's because my experience is that when you don't do anything stupid, when you avoid the different caveats that I've tried to point out, and you essentially trust the Erlang VM and the Elixir system to do the right thing, you get high enough availability for all purposes correctly. So you will have things dropping and restarting, but they restart quickly enough. That, from the point of view of your users and even the vehicles and the robots, things are fine. We had plans for a long time to do to replicate the servers, to have the whole fleet management be ready in 3 different instances and just load balance from one to the other. And it's completely useless, actually. We don't do that. If you have your supervision tree set up correctly and recovery procedures that are fine, and the client side on the other side, which is kind of aware of what happens when something goes wrong and the system restarts, none of this is trivial at all. But if you do that correctly and trust your supervision tree and supervision strategy, then it will probably, at least for all use cases, it completely fits. So that's most of what I had to say. I just want to come back with one last quote, not from a computer scientist, but from a financier. It's a colleague of Warren Buffett. And I just love this quote. It's remarkable how much long-term advantage people like us have gotten by trying to be consistently not stupid, instead of trying to be very intelligent. So I don't think there's any bit, I would say, of these last 40 minutes that has been exceptionally intelligent. But I do hope that it will help at least some of us be consistently less stupid and avoid pitfalls. And if I did that, well, it was certainly worth my time, and I hope it was worth yours. So thanks again to all my colleagues and peers.
Okay, we have 5 minutes for questions. Yep, okay.
Hi, thanks for the talk, first of all. When you were talking about missing libraries, one thing you mentioned is protobuf. And since we were using protobuf since, I don't know, 2015, and also in production without issues, on using X-protobuf library, I wondered what issues you encountered that made you actually write your own.
So the question was, what was the specific need that led us to write our own protobuf library? The clearest one was we didn't have the two libraries that existed at that time were not especially fast. And our own is about 3 times faster encoding and decoding, if I'm not wrong. And also they lacked strict type checking, which means the protobuf, what Protox, our library, does is that it decodes it defines an Elixir struct for each protobuf messages, and it just appears as Elixir as an Elixir struct, which has a specific type and can be used in pattern matching and stuff more easily, and we thought more user-friendly-ish, well, developer-friendly-ish than the solution that existed, and especially X-protobuf, which was the big pattern. Parts of it is personal taste. You know, X-protobuf would have worked. We believe our own solution was better for a specific need, but we can change.
One sec.
Hi. Firstly, thank you very much for an inspiring talk. It's refreshing to hear somebody using Elixir in production for a long time, and it's actually very stable. We need that confidence for somebody new to Elixir, like me. I have a question here. So the point 13 on our talk alluded to the fact that I think you're not using Erlang cluster at all, right? And you're only having one instance of the production server. And you essentially bed in the code to retry again if the production server doesn't reply in a certain amount of time, and then wait for Kubernetes to restart it. Is that correct?
Yes, that's essentially correct. The reason we're confident with it is that it's now been used on, as I said, on many sites all around the world, and we have fairly good performance metrics and monitoring on these, and we can anticipate most problems. But yes, it's not going to be, at this stage, it's not going to be a 9 nines, 10 9, 12 nines things that you for this you would need, of course, redundant Erlang VMs and stuff. We don't need that much right now. And we have, real live data that shows that it's enough for the needs we have. Yes.
Okay, last question, and then we'll have to wrap it up.
Yeah, I mean, for me, I wanted to ask, how do you actually control the cars? Is this, are they not autonomous, or do they controlled by a server, and that's why you have mentioned also, using GenServers for anything, passing messages? I don't know, just thought it may be interesting.
Why do you want to talk more about what the driverless car things, or the commands?
Yeah, I don't think there's going to be time, probably, but yeah, just interesting how you actually control it, because how do you use, what kind of scheme you use to control? They're not completely autonomous, right? You have a server that controls.
Yeah, we have so each of them goes. Well, first they can be completely autonomous. We can fake some of the fleet management part, especially for vehicles which are alone on a single well-defined site. We try to avoid it because we like the telemetry mostly, but they can be completely autonomous. It's just that if they're completely autonomous, they will just have a set line and never diverge from that. They will follow the same path. What the remote fleet management allows us to do is to react dynamically to customer or passenger requests. Like somebody would say, I need a car right now there, and it will just divert one of the other that are currently doing one line, so that and isn't needed because there are not many passengers there, and just goes right at this point. That's if it answer. If you want more about the really sensing and location technology, I can talk a little about that offline. It's not my field of expertise, but I've been hanging out with pretty smart people, so.
Okay, so one last round of applause for Serge. Thank you.